So as a second example of reversing the order of integration, let's look at this integral. Here we're trying to integrate from 0 to 2 on y, from y squared to 4 on x, the square root of x sine x. Now, if you're feeling adventuresome, you might try integrating it just like it is. I think you're going to find it pretty challenging. You might think about doing this using integration by parts, but give it a try to see what happens. It's going to get uglier rather than prettier. The trick on this is to reverse the order of integration. So let's see what that's going to be. First of all, let's draw a picture of the region we're talking about, and then let's see if we can see what the integral looks like going in the other direction. Right now I can see that y is staying between 0 and 2, and x is staying between x equals y squared and x equals 4. So let's look at the curves x equals 4 and x equals y squared. X equals 4 is a vertical line, and x equals y squared is a sideways parabola. I'm only going to draw the top half of it because remember, I'm only going between 0 and 2 on the y-axis. Now, there's a strong suggestion that the y-coordinate of this point is 2, but let's check to make sure that that's true by setting these two equations equal to each other. If I set x equals 4 equal to x equals y squared, I get y squared equals 4, so y is plus or minus 2. So that's correct. This point up here, 4, 2, is one place of the parabola and line cross. The other place is down here in the fourth quadrant. Now, as y goes from 0 to 2, x enters on the parabola and exits on the line. So it's going from x equals y squared over to x equals 4. Let's see if we can reverse the order of integration. So I'm going to have exactly the same region. But I'm going to think about slicing it vertically this way, so that I'm entering on the x-axis, which is the same as y equals 0, and I'm exiting on this top curve, which is the parabola. The top curve is x equals y squared, but if I rewrite in the form y equals, that's y equals square root of x. So I'm going to integrate from y equals 0 to y equals square root of x. The smallest value of x in this region is 0. That happens here. The largest value of x is going to be 4. So if I reverse the order of integration, on the inside, I'll have dy as y goes from y equals 0 to y equals square root of x. And on the outside, dx, where x goes from 0 to 4. The integrand doesn't change at all. The integrand is still square root of x sine x. Now let's see if we can carry out the integral. First of all, notice that when we integrate with respect to y, we treat all the x's as constants. So this entire integrand is being treated as a constant. So I'll have the integral from 0 to 4 of simply y times square root of x sine x, taken from y equals 0 to y equals square root of x, plugging in the endpoints and subtracting. Notice when I replace the y with square root of x, I have square root of x times square root of x, which is x. So I have x sine x minus, plugging in 0, 0 sine x. So I can leave that off. Now this one is definitely a job for integration by parts. If I let u equal x and dv equals sine x dx, then du is dx and v is negative cosine x. So applying the integration by parts formula, I'll have negative x cosine x minus the integral of negative cosine x dx. And notice that those negatives cancel. So I have negative x cosine x plus sine x. And all of this is taken from 0 to 4. So first of all, plugging in 4, I have negative 4 cosine 4 plus sine 4 minus 0 plus sine of 0, which is another 0. So maybe we can write this answer as sine 4 minus 4 cosine 4.